this Grasshopper tutorial, we want to model something similar to the Randall Museum Kinetic art facade, and I want to teach you how you can use these point shards in Grasshopper to produce something similar to this. So you can see I can control these by point attractors. I can define a series of charge, which is actually the point object we are controlling here. The magnitude can be controlled, and we can produce a series of extrusions, which I'm going to use the Vivo Plugin called the stellate accumulation in this tutorial. So be sure to watch the video till the end, because we want to take this step by step and produce it. It's really easy to use the field, and you can also combine that with different shards from the vector field menu. Before we get started, if you're new to our channel, welcome. Consider subscribing, because we have weekly tutorials about Rhino and Grasshopper. And if you want to learn Grasshopper step by step, you can enroll in our course and learn it. I'm going to put the playlist up here. You can see the lessons and the example files up here. Okay, let's get started from scratch. What I want to do here is to go to the surface and primitive, going to use a plane surface. So let's just bring that plane surface on the canvas. I'm going to use this bifocals plugin so you can see what I'm doing, and that's going to teach you easier to understand how Grasshopper works. Okay, we have a plane surface, and I'm going to give the XZ plane to this. So it's going to go to the XZ plane, and the input is a domain. So actually, if I give it a number slider, it's going to be from 0 to that number. So I'm going to just give this a number slider for the X and the Y, and change the size. Here we go. And now we have the base surface, which we want to produce those fields. To control the field points in this example file, you can see that we have used the evaluate surface, and that is going to help us to control the location of the point attractor. So what I'm going to do is to go to the surface and use this analyzes evaluate surface to evaluate the surface. The evaluation of surface, if I give that to the plane and right click reparameterize, it's important to reparameterize this surface. The reason is that if we have a surface like this, which is a NURB surface, it has a U dimension and a V dimension, right? And it's when you reparameterize that, it's going to go from 0 to 1 and from 0 to 1. So that is going to help us to control that, and then we can use simply an MD slider, multi-dimension slider, and use 2 of them maybe. Use the shift key to give both of them to the input, and now we can control the location of the point attractors. Okay, let's make this square so you can see it. Okay, that's going to give you the point, and we're going to use these as the location of the point attractors in the field. In the vector field section, you can see that we have a point charge. You can use also other things, but for this tutorial we're going to focus on the point. Give that to the point. The charge can be a number between minus and positive, whatever you want. Let's give this 2 number sliders. So I'm going to go to the Params menu and use this gene pool. Double click on it. We need 2 number sliders from minus 10 to maybe 10 with 2 decimals. That's fine. I'm going to give that to the charge. Okay, let's change that to negative and positive. There's also a decay of charge, how it's going to decay in space. You can also give that a number, but let's just assume that that's 2. We can change that maybe in another number slider. So I'm going to just double click that to 0 and 10 and give this a number slider. Okay. Now we have 2 fields. You can see that we have 2 fields. We have to combine that into one. So I'm going to go to the vector, and in the field there is always a merge field component. You have to merge those things together, so you have one unified field, so I'm going to merge them together, and here we have one field. Okay, how can we use these field components? In this tutorial I'm going to use only one, and that is evaluate field. That is going to help you to see how this field is going to affect a series of points. So how can we do that? We can simply go to the surface, use this utility and tool called divide surface. Divide the surface into points. I'm going to give it to the base surface, so it's like the plane. Because it's a square, I'm going to give the same number to the U and V count, and by increasing it's going to increase the resolution of those points. Actually, when you're using divide surface or this one, which is called also, let me see here, surface frames, these two tools will give you data in groups. You can see that this is divided into 17 groups of 17. So we don't need these groups, we have to flatten this. If you don't know about flatten or graph, I'm going to put up a lesson related. So here we go, just flatten this, so you have all of those points in 289 points in one group. Okay, now we can give that to the field, and it's going to give you a tensor, okay? Because it's going to be different in value, let me show you by going to the display and using this vector display. This is going to help you to understand that, okay? Let me show you. By vector display is going to actually display a vector from a point by defining a vector. This is the tensor or the vector. This is the points. Okay, let's turn them off. A problem we will have here is that when a point goes on a point, you can see it's going to give you a big chunk of a vector. So we don't need that one. How can we fix that? That's really easy. What you have to do here is to go here and type unit, which is a unit vector, makes it a vector length by 1, or you can go to the vector section and use this vector. Where is that? It's unit vector. It's like here. Okay, so we can also use that one. If I give that to the vector, you can see all of them are going to be in the length of 1. Now we can use that. If you go to the vector and go to expression, you can say maybe like 5 star x, that means 5 times. You can see them bigger. It's going to give you an overview of how those points are going to affect that. Okay, we can change the charge value here. You can see that's going to affect that. The decay is also important. It's going to affect the results. Okay, these are the inputs we have to change. And now that we have this unit vector, we have to play with it to produce something geometrical. I'm going to use a technique which I think you're going to like, and that's going to go to the plane in the vector field and use this plane normal. What does that mean? Assume that we have this vector in space. I'm going to define a plane which this vector is its normal, right? So I'm going to say, okay, give me a plane normal. The origin of the plane is going to be the points, and the z-axis is going to be actually this unit vector. It does already change the results, but that's going to give you a series of planes. Let's display them. I'm going to go to the display and preview plane size. Make that a little bit bigger, maybe 5. Okay, you can see that we have these planes here. Okay, and now I'm going to go to the curve primitive and use this polygon to make a base. So I'm going to give that plane to the plane of the polygon. Turn this off. And you can control the radius here, so it's maybe from 1 to 5.5. Based on your project, you can change that. The segments can be started from 3 to maybe 12, based on your project. I'm going to give it a 3, to make it a pyramid. And then you can also give it a fillet radius here. If you give it something bigger than 0, it's going to give that fillet radius, something like that. But because we want to make this as fast as possible, I'm not going to give this a fillet. And to make it fast, because if you want to use extrusion and NURBS, it's going to slow down the process. We want to see the results. What's going to make it fast is that we have to convert that into a mesh. That's ideal because we have 3 segments, and a 3 segments or a 4 even, 3 or 4, is ideal for a mesh. So this is a cool trick you can always use. If you have 3-sided, it means a triangle or rectangle, you can give a plane, a surface to it. That's going to convert it into a surface. Then go to the mesh section, utility, and use this simple mesh. The simple mesh can understand that this is it has 3 corners or 4 corners. So the simple mesh is the best solution to convert it into mesh. And now we have meshes, and meshes are really fast. What I want to do is also use the Vivo plugin. Be sure to install it. You can download it from our website or from foodforrhino.com. And I'm going to use this Vivo Slate Cumulation, this tool. Give the mesh to it. Turn this off. And the distance, which we can control maybe between 1 and 8 with 2 decimals. That's it. That's how we can visualize the fields, and then we can just turn off the plane surface. So now we can control completely by playing with these points, playing with the charge here. Usually use a negative and a positive one, and then you can also play with the decay. It's actually a radius that this starts to fade. Okay, and that's it. That's how we can use it. And now you can bake this into a layer. So I'm going to just bake this into a layer and close this one. You can see that we have this in Rhino. That's it. That was the tutorial of how you can use the fields to produce something similar to that. Maybe we don't need this one or this one. And I hope that you liked it. Be sure to like this video so you can see more of our channel, and subscribe. Thanks for watching. See you next time. Bye.